My name is Kathy Urfer. I'm the river steward, one of two in Vermont and New Hampshire for Connecticut River Conservancy. And then in the corner here is Jen Griffin, who, what is your title?
I work for Great River Hydro. I work on relicensing and compliance with our licenses for the hydros. My background is in fisheries, so I'm going to be providing a little bit of information about our fish ladders today after Kathy does her presentation.
Yeah, and she'll be correcting me if I misstate something. So I was going to do a presentation, and then Jen will follow up and be able to kind of dig in more deeply on the fish ladders in particular at the Great River Hydro facilities. So thank you all for coming to start. And as I said, I work for Connecticut River Conservancy. So many of you who've lived in the area a long time may have known it as Connecticut River Watershed Council. Our organization is 65 years old, and we've been working on the whole river from Canada to the Long Island Sound for, a little more than half a century. And we have river stewards in all 4 of our watershed states. So there's 2 that work up here in Vermont and New Hampshire, myself and Ron Rhodes. And we both work in both states, but we split our job a little bit more in terms of the content. So I do some regulatory and policy work. Ron does more of our restoration work, actually in the ground, removing dams that aren't being used, the smaller dams, and then also working with farmers or landowners on riparian restoration, things like that. And then we both do a lot of this kind of public outreach, education. We both are, get dirty at the end of September for our Source to Sea cleanup. And then we have a river steward in Massachusetts and also one in Connecticut. So the whole watershed, as you can see, makes up like half of Vermont, a little less than half of New Hampshire. So it's a big area to cover. So everyone's participation in helping to take care of the river is really appreciated. Eyes on the river and letting us know if you see things or stories, history, anecdotes. We love that. And then even though you have a larger population in Massachusetts and Connecticut, the area is smaller and the impacts are totally different at different parts of the river. So we are here, kind of almost right in the middle. Although this is not to scale. In fact, I think the Vermont and New Hampshire section is even longer. So when we think about how we work in an ecosystem, you start from what is impacting it. And because of our long kind of industrial history in New England, one of the big impacts to our waterways are dams. There's, as you can see, thousands of them, probably about 2,000 in the watershed now, which you wouldn't think. And many of them, most of them, are small. And in some cases, they're like hidden in the woods. We just took one out in Dummerston 2 years ago that was on a little stream in the woods. And when you think of the land use, right, there's a lot more trees now than there used to be. And there are people living in different places than they are now. So one impact. The dams on the main stem, there are, I'm going to say about 16 of them. A couple of them are breached, but 10 functioning hydroelectric dams, 6 of which are owned by Great River Hydro, or 8? You guys?
On the Connecticut River?
Yeah.
1, 2, 3, 4, 5, 6 on the Connecticut.
Yeah.
Yep, 6 dams on the Connecticut.
Owned by Great River Hydro. And then a couple, Turner's Falls Dam, and there's also a Northfield Mountain Pump Station in Northfield, owned by a company called First Light. And then the Holyoke Dam is owned by Holyoke Gas and Electric. And then a couple breached dams further up.
And which ones are breached?
There's Wyoming, Dodge Falls. That's not? Oh, see these questions. There's Wyoming.
There's Dodge Falls, there's Gilman.
Gilman's not breached.
No.
Yeah, I don't know.
Great River Hydro also has 2 facilities at the Connecticut lakes. There's the first Connecticut Lake, second Connecticut Lake, and then Murphy Dam. That's a state-owned project. They don't have hydropower on them. Murphy Dam does, but or actually Murphy Dam, they're looking into putting hydropower
Could you define breached dam? Like, is it just mean that it's not functional anymore, or is it all the way removed?
Breached means it's partly removed. So, part of it in a storm is broken off, or it's worn down over time, or it's, so the water is moving through, but there's still remnants of the dam there, which in some cases can be, a little bit dangerous. So the one of the breached dams further up has some like rebar sticking out in concrete. So we're actually looking at how, in those cases, we might be able to do a removal. In the middle of the Connecticut is a different beast than on a smaller stream. But so some of the ecological impacts of dams, and I am, we are standing in a fish passage facility at a hydro facility, right? So nothing in the world is black and white. I'm talking about some of the impacts of dams, but we all know that in this case, these dams are generating hydroelectricity, and it's electricity that we all use, right? So it's always trying to figure out the balance and the trade-offs. I would personally choose hydroelectricity over gas or nuclear, right? So not trying to vilify our hydroelectric dams in any way. But the way dams work, essentially you're, in a traditional sense, many of them you're holding the water back. And what that causes is sort of a lake effect behind the dam. And so in a free-flowing river, you have the water tumbling along, it's being oxygenated as it goes. Ideally, there's trees overhanging it, keeping it nice and cool. When you stop that flow, the water slows down, and when water slows down, it drops sediment. So it actually changes the bottom habitat of the river and creates sediment, and then the water also warms up, and depending on the size of the impoundment, will split into these different temperature ranges, which function more like a lake. So because of some of the large impoundments on the Connecticut River behind some of the dams, that's one of the effects that is occurring. The other thing is obviously the fish swim up and can only go so far. And as you can imagine, that change creates ecosystem changes. So the fish that have adapted, the fish and other macroinvertebrates and animals and stuff that have adapted to a riverine system are the ones that are living in something that more resembles a lake are going to be different. They may be warm water species, so we're losing some habitat and creating a different kind of habitat when we have dams in the river. So we have right now, each of the hydroelectric facilities, most of the hydroelectric facilities get what is called a Ferc license through the Federal Energy Regulatory Commission, and that license can be 30 to 50 years long, and then they will go through a relicensing period where basically we revisit that contract. It's really a contract with the hydroelectric company to use the people's resource to generate electricity. So revisiting that license is relicensing, and right now these three facilities on the lower part of the river here, owned by Great River Hydro, the Wilder, Bellows Falls, and Vernon dams, and also the Northfield Mountain Pump Station and the Turner's Falls Dam are going through a relicensing process, which is a pretty long process that involves multiple studies. In Great River Hydro's case, something like 34 studies over the course of several years to look at, the fishery, dragonflies, erosion, recreation, all of these things that the dam may or may not be affecting, to collect data and try to identify if there were changes in how the facility might operate. That information is to try to inform those changes. And just so you have an image, like these are the 5. All 4 of them, except for the Northfield Mountain Pump Station, are dams where there's essentially some sort of peaking. So it holds the water back, and then, at a certain part of the day, they will generate and move the water through. The Northfield Mountain Pump Station is a tube from a reservoir on the top of a hill down to the river, which is the reservoir at the bottom of the hill. And what essentially happens is water is sucked up from the river into the upper reservoir when electricity prices are cheaper, and then it's flushed back down when electricity prices go up. It also, another really important part of the hydroelectric facilities is their role in being able to start the grid from black. It's called black start. And jump in and correct me if I'm stating things wrong. But, if you think of a nuclear plant or a a coal plant or a gas plant, they actually need some electricity to start because the hydroelectric facilities are using the kinetic energy of the river. They can start from nothing. So if you all remember when we had that Northeast blackout in whatever, 15, that was 16 years ago maybe or something, we rely on the hydroelectric facilities to restart the grid in those situations. So they play an important role in our larger electric grid. So one impact, when you're speaking about the fish, could be dams. Another impact is climate change. And climate change in New England is, moving rapidly and intensely to change our habitat. So, temperature has increased. Oh, I changed this. I did change it.
Did you?
Yeah, okay, wait, so I'm gonna have to translate in my head. So temperature has increased by about 33 degrees Fahrenheit over the last century, and it's anticipated to increase, it was something right between like 32 and 37 by 2100. And then 1 meter is about 3 feet, right? Sea level will rise, well anyway, sea level is gonna rise. But one of the other things that's happening, particularly in New England, is our precipitation is changing, right? So we're used to snow that's actually kind of dry, and light, right? So older people can, shoveling. It's actually getting harder to shovel the snow because the snow is holding more water. And in the winter, we're getting more precipitation as rain. So what that means is that the snowpack is changing. And when the snow melts, how it's melting is changing, right? So it's entering our rivers at a different rate. The water is likely warmer. It's not been frozen. Not all of it has been frozen to the same extent. So even in terms of the temperature in our waters, right, in spring, that's changing with climate change. And then if you look at the other end of the season, July, August, September, there's less and less rain. So we'll have more situations where there's going to be drought, there's going to be lower water levels, it's going to be hotter, the water is going to be hotter, which means there'll be less oxygen in the water. So another impact, and you can carry this out to the ocean as well when we're talking about our migratory fish. Another impact is the changes in climate in terms of where our migratory fish are moving into and out of, where they're choosing to spawn, and the triggers. And we'll get into that a little bit as I go through the fish, and I should probably speed up here. But so migratory fish are something called diadromous, meaning they're kind of living in two places. And depending on the fish species, it may be that they're born in a river and then they live in the ocean, or it may be that they're born in the ocean and they live in the river. And then there's some that kind of just come and go as they please, but they need a little time to change their biochemical insides to transition between salt and fresh water. And our, maybe our celebrity sexy fish is the Atlantic salmon, because as many of you probably know, for a couple of decades, up until about 2011, we were trying to restore the Atlantic salmon population in the Connecticut River. That population was extirpated in the late 1800s. So what we were trying to restore was actually not native Connecticut River stock. It was from, I think, one of the rivers in Maine. And so, through a variety of reasons, and I don't think that the biologists actually even understand why, we were not successful in trying to restore that fish. And that may include the fact that they're swimming out to Greenland. It could include catch rates. It could include endocrine disruptors because of microplastics in the river, in the ocean. It can include a lot of different reasons. So the crowning kind of thing that really shut the program down was Irene, because the fish hatchery was along the White River in Bethel, and that got completely annihilated during Irene. So I think we were already struggling with trying to do that restoration process, and Irene sort of put the last nail in the coffin.
Yeah,
Maybe.
there were a lot of funds going to it with little success after 30 years of trying to get it reestablished or to get a population established in Connecticut that was from Maine. It's a little difficult. Some of the folks think that part of the reason is because the mouth of the Connecticut is a little bit too far south. The water is not quite cold enough for them, so Maine is much more likely place where they're going to be going. So that's some theory about why it didn't quite work in Connecticut for reestablishing the population there.
Are there none in rivers south of the Connecticut River?
I don't think so, no.
Okay.
Yeah, because next down from the ocean would really be like the Hudson. So,
It is. It's a cold water fish.
yeah, same like larger family as the trout. So, part of what happened in the process of trying to restore this particular species is as we were working on relicensing through the Connecticut River, valley, the fish ladders were mostly built for Atlantic salmon, to try to attempt to pass Atlantic salmon. In some ways, you could say that may be good or bad, right? Because as we'll learn, all the fish require different things. So I'm going to run through our fish, which some of you may love some and hate others. I love them all. Striped bass is not migratory from the perspective of needing to spawn. The striped bass generally spawn further south in like the Chesapeake Bay, Delaware Bay. They chase the other fish that are migrating. So striped bass will come up in the river chasing alewives and blueback herring as a food source when they're fattening up. And they will come up the river. Sometimes they'll go through the Holyoke fish lift, but they just happen to be in there because they're chasing their food source up and down the river. So they're generally staying in the lower part of the river in the ocean, and they actually migrate along the coast in the ocean. So as it gets, and I may say this wrong, as it gets colder, they will head back down south, and when it gets warmer, they'll start to come up into the northern areas to feed and fatten up. So they're migratory, but migratory in a slightly different way. I'll skip that. Atlantic sturgeon are essentially dinosaurs. They're one of the oldest, the sturgeons are some of the oldest fish that we have. Atlantic sturgeon in particular, and I wrote notes, but of course forgot them, does not come up very far into the river, but these are really long-lived fish. They'll live to be 60 or 70 years old. So in some ways they're kind of like our epic elders, right? You could think of them both from their existence for millions of years, but also just in each individual's lifespan. They have these they don't have scales. They have, it's almost like,
Scoots. They're called scoots.
Scoots, thanks.
They're armory, essentially.
Yeah. And sturgeon is where we get our caviar. So for the Atlantic sturgeon, one of the impacts to them earlier on was being fished for their caviar, for their eggs. Shortnose sturgeon come a little farther upriver. Shortnose sturgeon actually will pass through the Holyoke fish lift up into the Turner's Falls area. And then there's a bit of a boundary there. So what the biologists know now is that there's actually two sort of groups of shortnose sturgeon. One that have stayed in the river, kind of in the Turner's Falls area, that are spawning. But they're not necessarily doing their run out. Or some of them are. And then there's another population that comes up the river and kind of gets to the Turner's Falls area, but they're not spawning. So, what you'll see is there's a bit of a bottleneck at Turner's Falls, and we're trying to figure out, we meaning like all of us fisheries biologists and many people in the works here, trying to figure out how to cross that bottleneck and let those populations make sure that they are commingling. The good habitat for spawning for shortnose sturgeon is in the Turner's Falls area, and so getting them up past Holyoke is important. And this, to dig in a little bit on fish passage and the details of it, this is actually the Holyoke Dam, And so you can see this upper area is going north, the upper part, the water stops there at the dam, there's rocky area, and the fish are coming up this way to try to get past the dam.
This is an interesting site, just to throw in a little bit. Some of you probably know about this, but Holyoke, it's got all the canals, and those canals fed mills. So these are, some of these dams on the Connecticut River are 100 years old. You know, it's big dams. They were built for the mills when there was textile, when up here there was the timber. It's a lot of history, and it's a challenge for the biologists working on the fish here to try to figure out what's the best way to make this work, to get these fish up there successfully. And there are a lot of organizations involved, the federal government, state governments, the licensees, working on especially the shortnose sturgeon because it's an endangered species.
Yeah, and another consideration with the Ferc process is actual historic properties, right? So many of these dams are at least 100 years old, and so some of them are listed on the National Register of Historic Places. So there's some consideration about treating the facility, how you treat the facility itself. So the kind of cool and interesting thing at this facility in terms of how they solved it was they have this flume area, and I think this is kind of a before picture, but basically when the fish are coming downstream, you know, they're riding this flume down. And so what happens here at the bottom can be kind of important to how they survive that ride for any of you whitewater folks.
There is another bypass also that they can pass, but this is an area where they also can pass.
Yeah.
Two ways to get down.
And so one of the changes that was made at Holyoke, and Holyoke is very successful in passing fish. It's
Passing them downstream.
passing up and down.
Yeah, up and down.
Yeah, is they made an engineering change at the bottom of this flume to soften it so that it's safer for the fish as they're coming down, right? It's aerated, there's more bubbles, it's basically like a softer landing place. But the entrance to the fish lift, and in this case it's an elevator ride for these guys, which is good for other reasons. It's under this little, arc. So what happens is it's called an attraction flow under here to bring the fish in. There has to be certain velocity, the temperature has to be right, all of these things. And so the fish actually swim under there to get into the elevator. There's 2 elevators. And then as long as you can get them into the elevator lifts them up and puts them over the dam. One of the things that makes elevators maybe more efficient at passing fish is there's one problem of getting them in, right? And then you can get them over. Sometimes in the fish ladders, you have to get them in, and then they have to make their way through the ladder. And so there's another whole question of the engineering to help them find their way. So river herring there's blueback herring and there's alewives, and they primarily live in the lower section of the river. One of them, blueback, will make it up to Vernon? Yep. Yeah. Blueback herring will make it all the way up to Vernon when they're doing their spawning runs.
Some will get to Vernon. Mostly they'll get up to Turner's Falls. And if they get to Turner's Falls, they're excited about seeing big numbers of blueback herring at Vernon. The shad come all the way up, but
yeah.
The blueback don't get very far.
Yeah, and I would say most of them are spawning Connecticut, Massachusetts. The alewives won't get past Connecticut. Like they're going right into the lower streams in Connecticut to spawn. And so these are kind of considered like bait fish in some ways. But so here's an example for even when you get smaller streams lower in the watershed. Here's an example of a fish ladder to help to try to move those like herring and those fish upstream in the smaller streams.
This one is kind of neat. I worked on these when I was working in New Jersey. It's called an Alaskan Skeet Pass. It was designed so that they could take these and essentially drop them in small tributaries in Alaska. You see how it's like one piece? You can attach pieces. It's fairly small, so you're not able to get too many fish in there at the same time. But it's something that can be done relatively inexpensively. Get the right entranceway. You see that concrete area down at the bottom. We spent some time on making sure that they got the entrance right. And then the exit where you can either have them just go right through and up into the river, or you can put some kind of counting system in there, collection and counting, so you can see what's going through and know how many are going through and what you have passing it. So these are kind of neat, and they're good for small dams like this.
And then American shad. So, you know, in a lot of the East Coast rivers, there had been shad fests, and there are massive shad runs of these fish up the river. You know, and traditionally, these guys would come all the way through here. They haven't made it to Bellows, I think, yet. I was asking about Lael. Lael didn't count any yet. So, what do you know?
The reason I say I'm not sure is because the way our counting system works, and I'll get into that, is that it's a video recorder. So you have to actually go back and look at the video to know if you've actually got fish. And we're about, I don't know, 3 or 4 weeks behind in that counting.
Yeah.
So I can't say that they haven't been here, but Janelle's been here on Fridays and Saturdays, and I don't think they've seen too many. Last year, they saw them here by now. But it is a late year. Everything's a little bit late because of all the water, and the water's been cold, so everything's lagging a little bit.
Yeah, and I did bring copies of, which I can hand out after. We get sort of weekly updates of the fish counts of all the passages coming up the river. And so there were 925 who passed Vernon on May 26th. So if they're close, if they've few have made their way, but they're like on their way up. And so the shad have a pretty interesting life cycle. Some fish are one-time spawners, right? Your Atlantic salmon's going to come in, they spawn, and maybe they die. Correct me. They might do 2?
They come back 2 or 3 years at most.
Yeah. Shad is similar. They might spawn for 2 years or 3 years, right? So in this case, you need to get them up in the river to find appropriate spawning ground, and then they're going to leave again. And so you got to get them out safely, and that may have to happen, 2 or 3 times depending. As they're coming up the river, there's a certain amount of fat store, and so some of the studies that are looking at shad are actually trying to figure out how many times they've spawned, because if they're having to spend a lot of energy trying to navigate their way up, they're burning that spawning energy before they get to the place where they want to spawn. So trying to reduce the amount of time it takes them to get through the fish passage is really important in the reproductive, success of the species. And these are the fish that, you could walk on the back of them. I mean, they're, in a fully healthy river, you would be able to see them when they come running. So even though our numbers are higher and getting better, they're nowhere near kind of our historic highs. You could say that for a lot of species in general. So here is, there's management plans, especially for the species that are, considered threatened or endangered at some point in our 4-state watershed or federally. There's management plans for trying to increase those numbers. And the management plans include, anticipating how many fish would make it through the first passage. A certain amount are going to find habitat in those streams, and then how many should make it through the second passage and on up the way. So in an ideal situation, you would have maybe 50, a certain number come through Holyoke, and then 50% of those go through Turner's Falls, and then 50% of that go through Vernon and on up through Bellows, and maybe Wilder, depending. I mean,
the historical limit was the falls here. So Bellows Falls, they could not get past the falls historically. So that's the historic limit, and this ladder is not designed to pass shad. It's designed to pass salmon because that's what was passing. Historically, the salmon were going upstream. So shad use this, which is great, but it's not designed for them. And we do not have at this time a requirement to pass shad at this facility because historically they didn't go past here.
What about the other species?
She's going to go through some, and I can talk about some of those too. Migratory species. Also, the resident species will use it. We don't open the ladder specifically for resident species. It's for migratory species right now, but some will use it, not a lot, and most people use it in the springtime when they're open.
Yeah, and sometimes I monitored this ladder when I first moved here, and you can see some of the resident species. It's almost like they play in it, you know, they're like, oh, I'm going down, I'm going up, I'm going down.
I erased some of our numbers lately, but the 24 that we've seen, I think 6 or 7 were just smallmouth bass hanging out in there. So
Yeah. So in an ideal situation, you have this kind of passage through. When you start to count the numbers, this is what we're seeing now, is that, you know, we get a really good passage through Holyoke. When the fish get to Turner's, the passage is not functioning that well. But what gets passed through Turner's, almost all of them are getting passed through Vernon. So, you know, there's a big focus right now on trying to increase the efficiency of how the fish move through the Turner's Falls area. And depending on your facility, things are easier or harder, right? So Turner's is particularly complicated because, you know, this is the lower part of the river going south. In Turner's Falls for a very long time, you know, probably over 100 years, has been this power canal. And so the river actually separates, and you have what's called the bypass, but it's the natural, you know, older part of the river goes up around that way, and you have the power canal here that goes through, and then you've got the Turner's Falls Dam at the top on that curve. And so in this case, in order, you know, there's been less water in the bypass, so that can be a little tricky for fish moving into that area of the river. There is a dam here, and so you need one ladder or passage process to get the fish through here. If they're in the power canal, you know, it may not be the best place for them to go upstream. In both cases, if they get up to the top, then there's another passage to get over that dam. So they have to pass 2 obstacles to get up that way. And so, as you can imagine, it's much more complicated. Just getting through one passageway is hard enough, so trying to design for 2. And then there's different flows, right? So you have water that's possibly coming out of an outflow from a hydroelectric facility. You know, the fish are attracted to a certain velocity of water. So you have to trick the fish into not going this way, but going that way, right? So there's, right now in the relay sensing, they're examining a bunch of different possible ways to deter fish, to get them going in the right direction. There's a lot of possible ways that this might get solved over the course of the next, you know, 10, 15 years, or
We've been
however.
working on that site for a long time. And a lot of the Conti Lab folks, the USGS Society of Researchers have been looking at that. It's a difficult site. And the type of ladder, one of their ladders, is very similar to what we have at Vernon. And yet Vernon works very well at passing shad and salmon, but that one doesn't. So it's an art as well as a science to figure out what the fish is thinking and to get it right, to get that fish up over that spot.
Yeah, even to the point where how the opening looks, you know, I think the fisheries biologists are still learning like what it is that's going to make something skittish or decide that it's not safe. In some cases you can get them in, but then they're not going to go up all the way because there's something in the ladder that deters them. So, you know, if they could tell us, that'd be great. That's how I feel about my children before they were able to talk. It's like, what do you need? American eel. American eel. So American eel are resident fish in our rivers, essentially, and then they go out to the ocean to spawn. And I love talking to the kiddos about the American eel because they essentially, you know, travel out to one spot in the ocean, the Sargasso Sea, spawn, leave their babies, die, and then the babies have to find their way home. And so I always love asking the school kids, like, could you find your way home if your mom took you to New Jersey and dropped you there? When they are born or evolve in the Sargasso Sea, they start as these little glass eels, little tiny glass eels. And over the course of their lifetime, they change as they make their way into our East Coast rivers. So when they come up the river, they've gotten bigger, they've eaten, they've start to hit into some of the area where there's fresh water coming in, and then they change into what are called yellow eels. And then as they move further up into the river systems where it's freshwater, they become black eels. And one of the cool things about eels is they can climb, right? So as they move their way up the river, if there's an exposed wet rock, they will actually slither right up it to continue on their way. When they get up into the rivers, they live for how many years? Like,
Live for 25 years.
yeah, in a river system.
Before they go down, it's very kind of a variety, long, big range of ages before they hit back downstream.
Yeah. And they will head really far up, right? There's,
They go far up. It's really depending on how many are in an area. It's a density dependent kind of thing. They'll move upstream to find more habitat, to find food, that sort of thing. Another interesting thing is that they're not necessarily male or female when they're born. It can depend on the density of males or females in an area. If it's an area that has a lot of eels, they'll become male. And if there aren't so many, they can become female. And this is when they're younger, in the estuary, when they're first moving upstream. But it's kind of a cool thing. Eels are really cool.
Did you say 25 years?
Up to 25 years is, what I've seen in the literature, yeah. Not always. I mean, they can come down after 10 years or 5 years.
But they wouldn't spawn for all that time.
Exactly. It's, they're growing for that long and staying in an area and feeding for that long. And they may move around in an area. They won't necessarily stay in one lake or one river tributary. They may move around and go to another tributary. But it'll be up to 25 years before they go back downstream and spawn and then die. And then the babies come back up.
Both males and females go upstream?
Yes. I have seen that the males may go a little bit farther upstream than the females. The males are a little bit smaller than the females, but they can both go upstream.
Do they come to this area?
They do, yes.
yes.
I've never seen.
So they're essentially like resident fish in the river, except for the point at which they're deciding that they are going to go out to spawn. And they are often confused with this one, the sea lamprey. So in Vermont in particular, there's a difficult conversation to have about sea lamprey because sea lamprey are in Lake Champlain. And so our friends on that side of the state are actually trying to eradicate them from Lake Champlain because they're considered an invasive species. On our side of the state, they are native migratory fish in the Connecticut River and, are kind of get a bad rap because they're super creepy and they have this big mouth. When they are coming up the river to spawn, they're actually going blind. They have stopped eating and they're dying. And so they are one of the epic, creatures that are trying to find a place to spawn and then they die. And what that means is that they're recycling nutrients from the ocean up into the rivers. So they serve the river in a lot of ways in terms of bringing nutrients into the river, feeding the resident fish in the river. And this great little creepy sucker mouth is used in the ocean to attach to fish as a parasitic relationship, and they're sucking their blood and living on them. But it also comes in handy for building their nests. So what they do when they come up and find an area that they like, they take the stones and they turn them over and they make a little ring. And so you can actually find their redds nests in the smaller streams by seeing almost a circle of like white rocks as they turn the rocks over. The male and the female go in there and smush together, and you might explain there's a very particular chemical process that occurs with a male where he's got some fat on the back of him that dissolves or something like this. And you don't know about this? Oh, okay. Andy described it and I was like, holy mackerel. But at any rate, they mate, everything falls in the nest there, and then the sea lamprey, when they're little, kind of dig in, and then as babies, as it were, they sort of are staying in that sediment for quite a long time. And as they grow, it takes them, I think, a couple of years before they start to head out. And then they live in the ocean and then repeat that cycle. So
Yeah, they'll be in the Connecticut River. People see them in the Connecticut River that I've heard people talk
And we've seen 9 apparently pass, at least 9 pass the ladder here. So they come up in this migratory run with the other fish.
And the juveniles are in the river, along with.
Oh, sorry.
The adults are running out, but we definitely see those, but juveniles are in the river too. And you may see a fish that has a juvenile attached to it that is parasitizing.
Okay, and then, not migratory are freshwater mussels. So there's 12 freshwater mussels in the Connecticut River watershed. 8 of them are considered endangered or threatened, either on a state level or a federal level. When you get up this way, the main one that we're concerned with is called the dwarf wedge mussel. And the reason why I'm bringing the mussel up is that the way that the mussel moves through the system is dependent on one of 2 fish. This is a tessellated darter, but they can also move on a sculpin, I think a spiny sculpin. So when the mussels reproduce, they send out these things called glochidia. They attach to the gills of the fish. And the fish, as they move through the system, they will mature. The mussels will mature, and then they'll drop off in hopefully suitable habitat. So when you're thinking about the barriers of, possible barriers of fish passage, even for things that are resident in the river, it's important to help move those things in and out, both for, for instance, a trout, right, for species mixing, because you don't want to isolate populations, but then also in examples of this, like even for our mussels, it's important for those fish to be able to move through.
Thanks for watching this episode of Vermont Master Anglers. For more content, visit our Facebook page @Vermont Master Anglers. If you're watching us on YouTube, please like and subscribe.